All right, folks. Thanks for coming in. Thanks for finding us this morning. Welcome to today's session. This is how to build an AI-powered digital human on Unreal Engine 5. My name is Jeff Spalding. I'm a senior technical PMM. That stands for Product Marketing Manager. So let's get right into it. Today's agenda, we'll be discussing a quick introduction from my friend here at Lenovo, Shane. He's going to talk about some of the hardware we have powered in the Lenovo booth that powers what we call Project R2X. And I'll show you a little bit, demo a little bit later on. So once we talk about R2X, I'll show you how we can prototype with it, different use cases here. And then we'll go into how to integrate digital humans into games, right? How to go from prototype to production. And then I'll go into a little bit of detail about NVIDIA ACE and its technologies of how to bring AI models and run them on device. So without further ado, let me just introduce you to my friend Shane from Lenovo here, to discuss a little bit about some of the hardware they have.
All right, thanks, Jeff. I will be brief, everybody. My name is Shane Griffith. I'm the industry manager for Lenovo workstations. So our P series, everything from desktops like you see here to mobile and the P series monitors as well. Largely, I think what Jeff is going to show here in this session is videos and recorded, but I encourage you to come down to the booth. He has it all running live on one of our P7 systems that you see there. And what's kind of special about this system that I want to make mention to is the guys at NVIDIA have brought into the show the 600 or 6000 series Blackwell card. That's a 600 watt card, so one of the hardest ones to get right now, as many of you know. So we have that running in a special chassis. Feel free to come on down, open up the cabinet, take a look at it. It's really pretty cool. It'll be releasing sometime later this summer. Right now we're going through testing, but we anticipate that this chassis on both P7 and P8 to be able to hold 3 of those cards at once. So really good, powerful system that you can do a lot with, hopefully. So with that, I'll turn it back over to Jeff, and feel free to grab us, any one of us at the end of the session for more questions, and stop down and say hi.
All right.
Thanks.
Thanks, Shane. Okay, let's discuss a little bit about the evolution of the human-computer interface. So I want to set the stage here and just how far along we've come. So beginning in the 20th century, one of our main interfaces with a computer was punch cards, right? This was used about for 90 years. So punch cards, physical medium, we actually had to write the programs on punch cards. It was very interesting. A few years ago, before I joined NVIDIA, I was a contractor at the Air Force Research Laboratories, right? So this is about 10, 15 years ago. The principal investigator on my project, he actually was telling me his doctoral thesis, he wrote a program on the punch cards. Now this was in the 1980s still, right? So we used punch cards up until the 1980s. So he wrote his whole program. It was a stack of cards wrapped in a rubber band. He'd have to submit his job to the system. So most people weren't allowed in those rooms. So you have to have a technician to actually manually feed it into the computer, right? So you have to wait sometime a little bit later on to get his output, right? So he'd get his output and it'd be compiler errors, have to go punch the cards over again. So can you imagine how far we've come along? So if you went to the State of Unreal yesterday, you saw the UEFN, right? We had the assistant was powered by ChatGPT that can help you generate code. So look how far along we've come. So it wasn't until the 1980s where we started to move into a physical medium, right? Peripherals. We had a mouse and keyboard. That was our secondary input into the machine. So as a show of hands, who prefers a mouse and keyboard versus a controller for gaming? All right, that's about like 50%, okay? So I don't know if I have my friend Ike here in the crowd, but we rag him all the time. He's a controller, but you can get the best of both worlds. You can use a controller on a PC game, right? So whatever your preference is. I personally like using keyboard and mouse for FPS, but if it's a different type of game, I like using a controller. All right, so we all know what happened in 2007. This was the iPhone moment, right? Ubiquitous. Around here, it's the full screen touchscreen interface, right? So this became sort of the norm into the interface into computing, right? And then it wasn't until around 2022 we had the rise of large language models and the introduction of the world from ChatGPT by OpenAI, right? So this is very interesting because now you can speak to a computer in natural language and get a natural response, right? So what's next in the evolution of our human-computer interface? Well, here at NVIDIA, we believe that you can converse naturally with your computer through an interface such as a digital human here. So again, we're going to talk about the technologies to bring digital humans to life. And we'll do that through a demo we have called Project R2X. So Project R2X is a 3D digital human workflow. This is built on NVIDIA ACE. So NVIDIA ACE gaming avatar, this was actually introduced last year by one of my colleagues here. I think she's in the crowd. She discussed the NVIDIA ACE gaming avatar. She gave a great presentation that's available on YouTube. So we use that as the basis for Project R2X, right? At the time, I believe Allison, she showed you the full end-to-end workflow with a mixture of cloud models, local models on device. So the latency, it went through a full stack. But here with Project R2X, I'll show you a video a little bit later on about what we can achieve really low latency, end-to-end. So I can speak to Project R2X and I can get a really fast response. So Project R2X, it serves as a playground. You can test different AI models, different cloud models, and we can also integrate it with something called Langflow. Langflow is it's one of the most popular low-code, no-code agentic frameworks. So this will really help you test different use cases here. You can actually create your own nodes. We have an integration with Langflow that supports Project G-Assist. So if you've ever heard of Project G-Assist, it's available on the NV app as an experimental feature. Project G-Assist will allow you to control your PC, optimize your PC, launch games. You can do several of that stuff. So if you hook up Project R2X here with Langflow, you can ask her like, hey, Project R2X, can you optimize my PC for me? Or what kind of GPU do I have? So the possibilities are endless with Project G-Assist. So a little bit later on, I'll show you, once we integrate Project R2X with Langflow, we can use additional functionality from Langflow to achieve an agentic framework, okay? So the other interesting thing is not only can you use cloud models, but we can incorporate NVIDIA NIMs. So NVIDIA NIMs are NVIDIA Inference Microservices. Those are optimized containers that you can deploy on an RTX AI PC with Blackwell cards, or you can deploy those in the cloud, so in data centers. So we have those available as well. So once I show you Aki a little bit later on, we'll show you what's possible with Project R2X. So let's dive a little bit deeper into the architecture of Project R2X, right? So you can see on the left here, I have input from the user. Now, I have all these peripherals attached to the Windows PC. I can achieve speech through the microphone, input from the camera or the desktop, and I can finally get maybe textual input, data, files from the actual system itself. That input is then fed into a context, right? So we take, whether it's text, speech, image context, and we basically feed it into our agentic framework with our Langflow integration, right? So, for example, if I share my screen, I'll show you that a little bit later on, I can feed that image input into a cloud model provided by xAI. xAI's Grok vision model has really good understanding of vision. So if I send it a full screen desktop share or my web camera, it can help me understand what I'm showing on my screen, showing on my webcam, and basically give me a response for that. If I feed it in a file, we can put it through an embedding model here. So what an embedding model does is you take data and basically transforms it into a vector representation. That vector representation is then stored into a vector database. Why do we do that? Well, basically, we want to have a way for the machine to quickly search for data. So that's typical in what we call a RAG, Retrieval Augmented Generation. So after you ask a question, it can search the vector database really quickly because machines understand vectorize data and give you a response, feed it into the LLM, and basically give you a quick response. So all that ends up in our context. That context is then fed into our OpenAI real-time speech-to-speech model. So this is different. If you've heard of large language models, OpenAI has a fused model. This is speech-to-speech, so it can take in multiple modalities. I mean, it can take in text, it can take in speech audio. So speech comes in, and basically the OpenAI real-time generates a speech response that comes back. I take that audio data, and then I feed it into the NVIDIA audio-to-face 3D microservice. And if you stop by a little bit later on in Lenovo's booth, that service is running locally on my machine. So what does that do? From audio data itself, we can basically infer the blend shapes, the animation output to drive the facial animations in real time for our character, our 3D character here. So once I have those blend shape animations, that is fed into the Unreal Engine editor. In this case, I'm using UE 5.5, and we're rendering the facial animations in real time. So you can use this with any character. The Audio to Face 3D service outputs, we use the actual Apple AR kit. There's 52 bones that we animate. So as long as you can map those bones to any different character, you can actually achieve this with multiple characters. Now, the NVIDIA ACE plugin that we have available on developer.nvidia.com, the newest version is 2.4. Out of the box, we do support metahumans. So you can actually take a look, import your own metahumans, and animate that and have fun. All right, so let's take a look at Project R2X. I'm going to show you this video I captured a couple days ago. This is just my initial interaction, right? So I think this video volume will play.
Hi there. Great to have you here.
Hey, can you introduce yourself?
Sure thing. I'm Aki, your friendly digital assistant. I'm into gaming, AI tech, and digital art, and I'm here to help make your day a bit smoother and maybe even share a laugh or two along the way. What can I do for you today?
All right, so that's my initial interaction with Aki from Project R2X. So you can see the latency was low. This is a real-time recording. I spoke into the microphone. We sent audio data to OpenAI's real-time speech-to-speech engine. That outputted audio data back, and I was able to stream it into Audio to Face to produce a blend shape animation. So you can see the latency was really quick there, right? Almost instant. Typically, if you've interacted with other avatars, there's a slight delay, but this is actually a cloud model, and the internet connection's pretty good. On the show floor, we have a pretty good internet connection, but you can see the latency is really low. Let's ask a few more questions to Aki here.
Can you tell me an interesting fact?
Sure. Did you know that octopuses have 3 hearts? 2 pump blood to the gills, while the 3rd pumps it to the rest of the body. Plus, their blood is blue because it's copper-based. Pretty cool, right?
It's pretty cool.
Do you know what Unreal Fest is?
Unreal Fest is a big event for creators using Unreal Engine. It's typically a mix of presentations, workshops, and networking, all focused on game development, design, and the latest tech in the industry. It's a pretty exciting gathering if you're into game development or 3D design.
All right, just setting the stage here for my next video, but you can see, notice that Project R2X, we do have transparency, so we're using alpha blending. So in this case, the use case here, it was a digital avatar you can interact with on your computer screen. Again, this is being rendered in Unreal Engine 5. Latency is really low. Next, I just asked her basic questions. This is really good. She understood what Unreal Fest is. So that was in OpenAI's language model, but she won't know details. So if I ask her specific questions like, hey, where's Unreal Fest being held this year? She doesn't know a general response. She's only trained up to a certain point. So that's the limitation. But a little bit later, I'll show you how we can hook her up to Langflow to do an agentic framework. But first, let me show you this feature here where I can actually share my screen. So I'll go on the bottom here, I'll click share screen.
I'm going to stop at the gear store before I head out to Orlando. What do you suggest I wear?
For Orlando, I'd suggest something light and comfortable. The CUDA t-shirt or the GeForce t-shirt both look great and are perfect for warm weather. Pair it with comfortable jeans or shorts, and you'll be set for your trip. Have fun at Unreal Fest.
All right, so notice the conversation history still maintained, right? This was in the same session. She knew I asked her about Unreal Fest earlier. I asked her about this, and she was able to weave in the have fun at Unreal Fest. So this is very interesting. I did not actually end up getting a t-shirt on the way out here, but next time I'll get the CUDA t-shirt. All right, so you can see some of the limitations. I asked her about Unreal Fest, but she doesn't know current information. She can't search the internet. And I'll show you, once we hook up the Langflow integration, how that can achieve an agentic framework. So let's check this out. So basically, I'll go into the options, but let's ask her a question about this
What's
particular
on
topic.
news.lenovo.com?
I can't check that right now, but you can visit the site to see the latest from Lenovo. Anything specific you're looking for?
All right, so limitation right there. Can't check the website, so I'm going to stop the session here. I'm going to change my connection to hook up to my Langflow server running on my desktop. So I supplied my Langflow ID, and that you can see here in the right side of the screen. We'll hit play and basically start the session.
Hi there.
What's the latest on news.lenovo.com?
Hold on while I check the latest news on Lenovo's website. Here are the latest highlights from Lenovo's news site. 1. Lenovo and Motorola partner with FIFA Club World Cup 2025. 2. Tech driving business innovation with Lenovo and DreamWorks. 3. Lenovo CFO discusses earnings and AI strategy. 4. Lenovo's AI collaboration with NVIDIA recognized in enterprise AI. 5. AI blending with wildlife conservation for a smarter future.
Okay, so you get the idea. I'm just going to fade it out, but that looks pretty good, right, Shane? So that's correct. So you can actually see, we can see the tool calling here in Langflow. It actually called one of the tools here. This is fetch content. It basically fetched the content, retrieve the JSON result, and this is what it supplied to OpenAI. So you can see it enumerated that. So none of that was actually in the prompt. Project R2X was able to use Langflow, determine that I basically was asking for a tool call, initiated the call, went to news.lenovo.com, scraped the site, returned the JSON, and fed it back into the OpenAI real-time speech and generated that. And you can see the latency was really low. And we had little nuances here, so you can see she was actually thinking, she was animating. So those little kind of nonverbal responses just make it more kind of interactive, more immersive as you're speaking to Project R2X. So this is an example of our Langflow integration. So let's do a little bit more use cases here. Let's say you're a game developer, you want to test out different prototypes. Another feature we have with Project R2X is the ability to ingest documents, right? So I was able to speak into the microphone, I was able to share my screen with vision, but now what if we want to process data? So in this case, I have an example game lore. This is a 60 kilobyte text file. So one of my colleagues generated this. This is called the World of Eldoria. So he used a language model to basically generate a fantasy world. It's got, 60 kilobytes of text is a lot. It's pretty good, a couple thousand lines of just straight fantasy. Sets the stage, different characters, different battles. I'm going to take that document and basically it's going to ingest. So as the architecture I showed you earlier, we're going to take that data and we're going to put it through an embedding model. We're going to chunk up the document, feed each part. In this case, it could be sentences, could be paragraphs. We're going to convert those into a vector representation and store it into a vector database. Why? Because later on, I'll ask Aki a couple questions, right? Like, hey, can you tell me where the inn is? Or who is this character called Finn Brightwood? Now, normally a large language model doesn't understand that. But if you put up what's called RAG, retrieval augmented generation, it can go and retrieve documents from the vector database and do what's called a similarity search. So machines are very good at doing similarity search against vectors. This is why we want to embed text into vectors and store them in a vector database. So let's check this out. I'm going to drag this document to R2X and see if she can understand questions about this world. So I changed the prompt. I said, you're an NPC in the world of Eldoria. Answer questions based on the document I'm going to provide you.
Hi there.
And I'll drag over the document. It's really quick.
I've processed the contents of the file, which provides detailed information about the world of Eldoria, its geography, history, magic, and key characters and locations. If you have any specific questions or need further details, feel free to ask.
Where should I stay for the night?
For a cozy and welcoming stay, you might consider the Rusty Tankard. It's a small, old inn located in a quiet corner of Eldoria. The inn is known for its warm hearth, hearty meals, and the fair and just innkeeper, Garving Stonebrew. Its comfortable atmosphere and friendly clientele Make it a charming choice for your night's rest.
All right, so that was interesting, right? She was able to describe the world of Eldoria. So I'm going to stop it here. I'm going to do a little bit more. I can select what's called a different voice, right? So these are voices available from 11 Labs integration, but I'll play another voice from OpenAI. We'll use, I think, Sage here. So I use Shimmer. So this is the Sage voice from OpenAI speech-to-speech. And we'll just test out like a different voice and see what it sounds like.
Hi there.
Who is Finn Brightwood?
Finn Brightwood is a young farm boy who grew up in the quiet countryside, far from the bustling city of Eldoria. Raised on a small family farm, Finn spent his days tending to animals and working the fields.
All right, so you can see the response there. So this is good. We can test out different use cases, test different characters, different voices. I can drag and drop in game lore. You can see how fast the iteration was. So this is interesting. If you want to breathe life into your digital characters, this provides you a way to, like a playground, to quickly prototype. So how can we go from prototype to production? How can we bring digital humans into games here? So first, I'll set the stage here and just kind of state the obvious that replicating human decision-making is difficult, right? But let's take a step back here and just what we saw with Project R2X, right? So first, we have to think about the perception, right? Giving the machine the ability to understand audio, vision, text, different supports, different modalities. Once we give these characters a perception, we have to give them the skill of cognition, right? How to choose what to do next. So cognition could be based on different language models, different function calling to basically reason. So that's the next step. Once they make a decision, how do we act on those decisions, right? Can we choose an action? Can we actually make a function call into your game engine to do something, to make an action? Or an action could be simply a response. Can we generate speech? Bring our characters to life. As you saw with Aki, we generated the audio that I got back from OpenAI, but we're going to talk a little bit about how to do that on device, in your games, in process. But how do we incorporate memory? Just as I showed you with the document, we can incorporate an embedding model. We can make informed decisions based on past actions, right? So before, she understood that I was talking about Unreal Fest, and next I was asking her, hey, what t-shirt should I wear? So just from the memory, from the context alone, or you can use an embedding model with a vector database to incorporate basically game lore, knowledge base, character interactions. We can basically have motivations for our characters to make informed decisions. So realize this is the 4 pillars of what replicating human decision making is. So it doesn't stop here. Let's expand on this, right? So in this central pillar, we still have perception, cognition, taking action, and memory. These are different models from our NVIDIA ACE stack of technologies. So think of NVIDIA ACE as a suite of tech. These certain models, and I'll talk about that a little bit later on, allow us to bring human decision making to our digital characters. So combine that with our user interaction, whether it's in the form of speech from our microphone, our camera input, or even just raw input, whether it's text or movements. We can actually feed that into our different models here, whether to understand audio, understand vision as you just saw, or basically use that data and embed that data. We can feed that into the planning and reasoning models, our large language models, in this case, a small language model on device, and basically take action, whether it's a form of speech, we can plan different actions, or we can do function calling, as I showed you with Langflow, call different tools, use an agentic framework. Now, all of this is actually wrapped up in our technology for facial animation, which is called audio-to-face 3D. One thing to point out here is the NVIDIA ACE stack is a mixture of cloud and local models. So using our NVIDIA NIMs, and NVIDIA Inference Microservices, you can deploy those on device, whether it's through Windows subsystem for Linux, or you can use, I'll talk a little bit later on how to get those natively into your game, or you can deploy those in a data center. So let's focus on the right here, the facial animation, our animation and rendering tech with audio-to-face 3D. Now, audio-to-face 3D, that is powering our real-time facial AI animation. The plugin for ACE, we call it the 2.4 Unreal Engine plugin, that is available now. So if you go to ACE on our NVIDIA developer website, you can actually get the Unreal plugin engine, try it out. The audio-to-face will run locally there on your machine. And this is interesting because not only do we have just a model here, we also have a training framework. And this is great because now you can apply custom model training, right? A couple of benefits here. Different customers can actually train their own ACE models. If you have their own actor to have different nuances here, we actually train audio-to-face on 2 different actors, a male and female, but you can incorporate your own training to actually get specific nuances of their face, verbalizing different audio and emotion. You can do platformer-specific identities. So in Project R2X, I was just using our actor called Claire, but a little bit later on, this next video, I'll show you another platformer-specific ID called James, where he's actually used as a male. We can verbalize that with our different actor. And then also, audio-to-face, we support multiple languages. This is very important because now you can localize. It's a turnkey localization effort. So we support many languages out of the box. So Gone are basically converting to different localizations. Once you get audio-to-face, you can actually integrate it into your own engine. We do have a native Unreal integration, but if you're using a different engine, of course, in a different conference, you can use our audio-to-face SDK. So again, different versions of audio-to-face. You can run it locally, you can run it in the cloud, or you can run it maybe on-prem a different server. So down at the bottom here, we have several different integrations you can test out in our Maya ACE audio-to-face plugin. I highlighted here the Unreal Engine plugin, or you can basically try it out on build.nvidia.com and just basically test out our web app. So again, available now with our ACE Unreal Engine 2.4 plugin. So let's take a look at this next generation audio-to-face 3D. So what you're looking at is a capture of James, one of the actor that we use for audio-to-face. So this is using the new diffusion model. So let's take a look at the animation here. And again, I'm just feeding audio and we're generating the blend shapes in real time.
Action.
Yeah, no, I've seen that before. Yes, that's perfect. They're going like 30 miles an hour. Why are you in the fast lane? Ooh, that felt good, didn't it?
Cut. Perfect.
All right, looks pretty good. So again, you can notice the eyebrow movements, different emotion. We have another use case here with audio-to-face. This is highlighting the differences between our new diffusion model and our older regression model. So why don't you take a look at the enhanced lip syncing and emotional range, okay? So we'll play this video. Again, on the left, we have our older regression model. And on the right, this is our new diffusion model, which was just released, I believe, about a month ago. Let's take a look.
All right, team, we can do this. Let's give it our all no matter what. We've got this. I don't know what to do anymore. It hurts so much, and I just need someone to understand. We've lost so much, but we will not be defeated. We stand together, and we fight for our future.
All right, so pretty good. Pretty good. Now, the other feature we have audio-to-face 3D is the support for multiple languages, right? So again, this offers turnkey localization. Depending on what the audio is coming in, it can infer what language it is and basically come up with a really good blend shape animation. So let's take a look at James here using different languages in real time.
In this game, every move is calculated. Our decisions now will define our future. 在这个游戏中，每一步都经过精心计算。我们的决定将决定未来。Dans ce jeu, chaque mouvement est calculé. Nos décisions maintenant définiront notre avenir. Iskelme, 하거든所什么期可乌太压价的，하마리 니니, 앞 하마리 100% 그 바리 바시 그 언제.
All right, that's pretty good. So again, this is our audio-to-face 3.0. This is available in the ACE plugin. You can test this out in Unreal Engine. So now that I've talked about all these technologies, right? How do we actually bring it on device instead of using cloud models? Well, we can do that with our SDK, which is called IGI, right? This is the NVIDIA in-game inferencing SDK. This will help you streamline your in-process AI deployment. So in-process means I'm running it in the same process as my game. This is a C++ SDK. We support on-device inferencing across several different models: speech, audio, visual, and basically small language models. And this is for in-process, on-device execution. What's nice about the IGI SDK, we realize this offers a unified API. So multiple different inference backends. We support TensorRT, Onyx runtime with DirectML, and then the GGUF format, which is popularized by Llama CPP. So no matter those different backends, we have a unified inference API that can work. So you don't have to sit there and mess around with different SDKs to get these language models to work. This can all run through the unified API for the NvIGI SDK. So this will work across different hardware accelerators, whether you're running it on any GPU, CUDA-enabled GPUs, an NPU, or the actual CPU itself. So one of our models does support inferencing on the CPU, and I'll talk about that a little bit later on. And then the other key thing here of the NVIDIA in-game inferencing SDK is integrated graphics execution. We can do that with a process called SIG, which is simultaneous compute in graphics. So that allows us to run graphics and AI workload with low latency. Gone are basically the context switching. So this is very important for maybe your engine developers that wonder how to run AI workloads alongside graphics, right? Because we know that's definitely a problem. We want to have maximum frames. We don't want to take away from the graphics rendering, so we can do this with low latency with SIG. So how does NvIGI work? Well, there's 4 components here I want to talk about. We have our core plugins. That's very important because those plugins provide the AI capabilities such as ASR, which is automatic speech recognition. We can run ASR either on the GPU or the CPU. We can run small language models, or we can run vision understanding models. And finally, we can run an embedding model to enable retrieval augmented generation. Those are our core plugins. We also have plugins that help basically set the stage, and we call those our helper plugins. This will enable things like SIG, compute and graphics, maybe network communication. We do support generating your own plugins, so if you want to talk to different cloud endpoints, that'll work with the helper plugins. And all this is wrapped up in a unified API. So since it's a plugin architecture, instead of messing around with different SDKs, you can basically go all through the IGI API, which will help you out with plugin management. And finally, really important here, local execution. We're not executing these models in the cloud. There's no more cloud costs. You can run these models on device in process using several different hardware configurations. So this is how IGI works in a nutshell. And for my programmers in the crowd, if you're wondering like, well, how do I get started, right? Well, this is very easy. I'm going to go over this really quickly, but basically this QR code, this is one of our tech blogs that discusses how to get started with IGI on device. So if you go here, we have this technical blog. I'll talk a little bit about some of the C++ code of how to enable IGI. But basically, once you get the SDK up and running, download some models. You can basically initialize IGI here. We just set up different log levels, our different paths to the different models here, and we just check to see if it actually loaded okay. So once we initialize IGI, we basically want to load different plugins. Now, this is mix and match. If you only want to run maybe like ASR or maybe a TTS plugin we have support, you can do that as well. So this is an example of loading plugins. For example, I'm going to use the GPT plugin. We call this GPT, Generative Pre-trained Transformer. This is one of our SLMs. This can support GGUF-backed formats. But basically, you can see here, I'm setting the model parameters. I'm just basically specifying the number of threads this runs on, how much budget and VRAM specified in megabytes, and then basically which model I'm using, this specified by the GUID. So once that is loaded, basically I create the interface, and I can start using the plugin. So down here, the code on the bottom, we're just simply creating the instance and just checking to see if it's available, right? So again, QR code up on the top right to basically give you a primer of how to start this on device with C++. So once we load the plugin, we want to create the runtime configuration. So you can see at the top here, the C code, C++ code, this is specifying the NPC prompt, right? Just I specified earlier, we can specify something like you are a helpful NPC, named TJ in a fantasy game, and we can do some limits on that runtime. We can maybe limit the tokens to predict, if that's very important for you. So if you don't want him to generate like a novel response, you can limit it to 200 tokens. You can make it interactive with multi-turn conversations. And then down here at the bottom, we're just basically specifying additional parameters as our inference context. So once we create the runtime configuration in inference, now what's next is we can actually send input to it. So this little code here in the middle, we're just specifying an example user input, asking a question like, what's your name? Setting up the different slots for input context. And then finally in the middle here, this is the code that actually executes the evaluation. And we run this asynchronously, meaning we send the response and we have to wait. To do that, we use what's called a callback function. And I'll show you that in 2 slides a little bit later on. But basically, you can see how easy it is. Unified API. No matter what plugins you use, it's all the same. You initialize IGI, you load the plugin, you specify the parameters, and you just do your runtime inference and wait for the callback. So this right here, this is probably the most important part I want to focus on. This is enabling our GPU scheduling and rendering integration. This is basically allowing us to do what's called SIG, compute and graphics. Once I get the IGI interface, I want to check to see if there's no errors. Once it's OK, I set up our direct 3D D12 parameters, just making sure that I can use this for rendering, right? So we want to do simultaneous AI workload and rendering. I want to enable SIG. To do that, we just simply get the interface for IGI, and we just call this simply function, enable compute and graphics, and I pass in my D3 D12 parameters. I just check to see if there's no error response. We're good to go, and I just print out to the standard output that computer graphics enabled successfully. This is for logging. Now, what this will allow you to do is when you're running a game, C++ game in this case, right, natively in Windows, we're going to do the inference in real time. I'm going to make a call. I'm going to specify the callback function here. You can see once I initialize this, and I basically send in the prompt. In this case, I'm going to try a different one, right? You're a helpful NPC in a fantasy game. Respond thoughtfully to player questions. And at the bottom here, I just call evaluate, pass in my context, making sure that there's no error messages. And a little bit later on, the callback function will return, and I can print the response from the NPC to the standard output. So simple as that. So again, top right, this is our technical blog to get started, but you don't have to do this manually. Here is an out-of-the-box integration with Unreal Engine 5.5. This is available on NVIDIA GitHub. This is the QR code for that. Please check out this sample. This is a minimalistic code sample to show how to get IGI working with chatbots. In this case, we're using a small language model into an Unreal Engine application. So again, you can see this is very minimalistic. All we have is an Unreal level. We have a chatbot interface. This is using the NvIGI SDK. So you can take a look at our blog, understand, go through the code, see how that works. But if you want to just get rolling out of the box, please check out our sample here. All right, so what models do we have available in NVIDIA ACE? These are the ACE models we have available today. There's quite a few, and I've highlighted different sections here. At the top, animation. Audio-to-Face 3D SDK that supplies our animation data. I feed it audio, it responds with blend shape data. Languages, we have a couple different models. We have the Mistral 7 billion parameter instruct model that works through our Onyx plugin, meaning that we can run across different hardware configurations. Any GPU that can support Onyx can run that plugin. We also support our Mistral NeMo family of models. We have our 2 billion parameter, 4 billion parameter, and 8 billion parameter variations. These are all distilled down from a larger language model that was 12 billion parameters. So this is very important for maybe function calling, instruct. We also support our vision language. This is through our NeMo Vision 4B instruct, so it can understand images. I'll show you an example a little bit later on how that works. And then memory, I think I discussed this earlier. We actually use specifically the E5 large unsupervised embedding model. This can support your retrieval augmented generation. For speech, we have several different models here. We have Riva text-to-speech. That is one of our in-house models to generate speech. This works on device. You don't have to use a cloud model. That'll work on device. To understand ASR, which means like we convert audio to text, we can use the Whisper from an OpenAI, that's ASR, that can run both on the CPU or GPU. So you can mix and match and see how much VRAM you're using. We have another model called Riva ASR that is an ASR model as well, so you have options. And finally, we're working with Cartesia, which is another really popular text-to-speech. This is going to run on device, so this is coming soon. Please look for that in the next coming couple of weeks. And for object detection and character recognition, these two models are being used in NVIDIA G-Assist, right? We have our real-time detection transformer. Basically, we can identify objects in a scene. And we have our optical character recognition. So the OCR, this is very important if you want to recognize text in multiple different use cases here. So this is a slew of models we have available for ACE today. Let me show you how some of these models can work. So for example, with our Mistral Nemo family of reasoning models, we can do a use case here. Because remember before, human decision-making is difficult. How do we give cognition to characters? How do we understand different scenarios? So for example, if I'm planning something, I'm using maybe a co-player character, maybe like a bot that can fight alongside you if he's in a squad. In this case, planning is I want to survive and support my teammates as they loot high-value items, right? Because I don't want him to take my stuff. I want him to support me. But there's different actions that the bot can take, whether they can follow you, engage with the enemy, pick up loot, hold position, eat food, or maybe like answer a teammate. Those are the available actions in your game engine. But the motivation here, the prompt I'm sending to this SLM on device, given this plan and the available actions, select the best one. We feed all this information to the SLM. This is running on device, and it can choose the best response here. In this case, it should follow me, and then eat food in case the HP is low, right? So you can do this with our Mistral Nemo family of models. This is very good for instruct reasoning. Here's an example of our vision language model, right? This goes to our perception, our idea of perception, giving the characters ability to perceive. Now again, this is our Cosmos VLM, vision language model. This is running on device. I can feed in two different inputs here. I can feed in an image, and I can basically ask the prompt here, describe this image, player status, and any relevant information on the mini-map here. So once I feed this input into the SLM, or excuse me, the VLM, we get this response, right? Players in combat, time is 12:38. There's an enemy directly ahead of the player, right? So we can use different scenarios because we understand from talking to multiple developers, game state may not be always available, especially from a perspective of different players on the screen. So if you can feed in a text prompt, maybe a vision from their perspective, these vision language models can help you understand and basically describe what's given to them. So very powerful. Again, this is running on device, in process, through our ACE models here. Next up, I talked about this briefly, but basically our embedding model allows you to achieve what's called RAG, retrieval augmented generation, right? So essentially we can input game lore, rules and systems, character backgrounds. We can take that data, feed it through our embedding model, and basically store the vector representations into a vector database. So again, you don't have to fine tune your model. This is very important. You have a small language model, but maybe your data might change, your knowledge base, your facts, maybe real time as your character explores the world. If there's certain events happen, you can basically take that and put it into our embedding model. All right, so finally, last model here, this is our Riva text-to-speech on-device model. I can basically take a text prompt, feed it into our Riva TTS, and we can produce audio. Again, this is running on device. This is an example. I basically took one of our characters, our input voice was, I have an actor that was basically in like a sad. So that was the input voice. I'm gonna try to clone it and basically make him say this phrase.
I never wanted this to happen. If only I had listened, maybe things would be different.
All right, so again, that is on-device text-to-speech that's running through ACE that can run in process. So check out these models. You can basically mix and match. Some of them run at really good VRAM usage, your specs, but depending on your game, depending on your use cases here, might be different for you. So I have one little treat for you before I go. I asked Project R2X to give us a wrap based on NVIDIA, Lenovo at Unreal Fest. So I captured this last night, or a few nights ago. I didn't have my microphone, so I had to type in. So you can see another different modality. Let's see if she can generate a farewell rap song about attending my early morning meeting.
All right, here goes. Yo, it was early, but we made it to the Unreal Fest. Lenovo and NVIDIA bringing their best. Talking about digital humans so lifelike and neat. Now we wave goodbye, gotta get some more sleep. Catch you later, keep it real and fun. Until next time, when we reunite under the sun. Okay, so maybe not Grammy material, but hey, it's all in good fun.
Please stop by our booth at Lenovo to come check out Project R2X and experience it live. This is a QR code for getting started with ACE. And thank you very much for your time. Please feel free to stop by in the Lenovo booth. I'll be there, one of my colleagues are there, and we'll basically answer your questions as well. So thank you very much.